Hello and welcome to my talk. We're going to go ahead and get started. This is a talk about what has gone into the Spring Framework over the past year in version 4.2, specifically focusing on items and features of interest to web applications. So we'll talk about Spring MVC, and we'll also talk a little bit about the WebSocket messaging side of things. I am a Spring Framework committer. I've been involved with Spring MVC for several years now, and I've worked also on the WebSocket messaging side of things. And there is a GitHub repository with source code for this presentation. So we'll do some demoing, and I'll also make the slides available later on today. So you can find that on Twitter. So the first topic is related to HTTP streaming. Just a little bit of background on that. Could we lower the volume a little bit, maybe? So for HTTP streaming, a little bit of background. Really, the motivation for that is to provide support for server-sent events. That's the primary reason or the starting point for this feature. Now, we've actually had support for asynchronous requests with HTTP since 3.2, which is about 3 years ago now. And originally, when we started out, actually, I'm going to show that is, there was a blog post at the time that talked about different techniques for real-time updates for web applications. This was actually a multi-series blog post when we introduced asynchronous request handling. So this was basically based on a feature that was provided in the Serviet API that was introduced, which we had first-class support for. And you can see here the gradation from traditional polling, which would be basically continuously polling the server to find out if there's anything new, because you want to display that on the page as soon as it's available. So if you have something like chat is kind of the ubiquitous example of that, where it's sensitive to latency. You want to show that on the page as soon as possible, as soon as it's available. And one way to do that is by using traditional polling. Now, a slightly smarter way to do it, or a little bit more effective, is to do it through long polling, which is when you start a request to the server, and the server doesn't respond immediately, but hold on to that request in order to provide the response when the information actually becomes available, which means that you don't have to poll continuously, and the server has a chance to send something, has a connection, it's sitting on a connection that it can send a response back on. And of course, if you have a lot of events flowing all the time with high frequency, that means that long polling becomes very much like polling, because the server has something to send immediately, and the client has to keep requesting more information. Now, yet another option here is for HTTP streaming. So this is where the client makes a request to the server, and the server starts sending information back to the client without closing the connection. It's just basically using that same connection, that same response to send multiple things over time. And there's, of course, the WebSocket protocol, which is the full messaging option. We have full duplex. The client and server are using a connection to send messages to each other. Right, so in Spring 3.2, at the time, we provided support for async request handling, which is effectively the ability to get off the servlet container thread. You're not holding the thread from Tomcat or from Jetty or any servlet container. And you're going to complete processing on a different thread, and then when that is complete, you can then send the result back to the client. Obviously, if you're doing anything like long polling, you really don't want to hold on to that servlet container thread. Especially if you're waiting for some kind of external event, something that's coming from a messaging system like JMS or Rabbit, something else. In that case, you really want to release the Serviet container thread, and then when you have the information, that's when you can actually write to the response. So that's the fundamental capability which the Serviet container provides. Now, what we did at the time was that we said, okay, the way we support that is you can take any controller methods, and whatever the signature is, whatever the return value, it may be response body, it may be something that's going through view templating, and you replace the return value, whatever that type is, and you simply wrap it with this thing called deferred result. And you simply return, and the application at that point will exit all the way out from the Serviet container thread, from the filters, etc. And you're free then to complete the deferred result at any time, either with an exception or with an actual result. And the advantage of that was that it's really supporting the full range of Spring MVC programming model. That's basically the value of what we did there, to make it really easy to take what you know in Spring MVC and be able to make that asynchronous now for whatever the use case may be. And that enabled a new range of use cases for doing things like long polling, chat, live events, the ability to send that information to the browser as soon as it's available without necessarily polling all the time. Or maybe you're doing something which has latency built into it, like scatter, gather, or microservices, in which case you know that it's going to take longer. You want to hold on the Serviet container for, so it's suited for that. And the bottom line here is that this is something which is easy to introduce into existing applications. That's was sort of the lesson from that you can make a web controller asynchronous without too much change. Then in version 4, we introduced WebSocket messaging support, which is, again, full duplex messaging. In addition to that, we also added SockJS emulation, which means that you have a WebSocket-style API and client. This is both on the client and the server side, and they can send messages to each other. And then if for any reason there's no ability to use WebSocket, maybe you're running in Internet Explorer 7, 8, 9, or maybe the network is actually, there are proxies in between which are not configured to understand WebSocket traffic. In that case, we automatically fall back on further options like HTTP streaming and long polling, but the interesting here is that happens automatically. You're still using a WebSocket API, and under the covers, a different transport is being used. So this is now a slightly different level. The other opportunity with WebSocket is that you can plug in a sub-protocol, which means a higher level messaging protocol. So just like when we write web applications, we're using a TCP connection, but you're not actually working directly with the TCP connection with a stream of bytes. You're using a protocol on top called HTTP. And that's the application level protocol, which gives you the mechanisms for delegating requests to specific controller methods. It gives you HTTP, GET versus POST. So those are things which we can build a framework around. Similarly, with WebSocket, it's very, very low level. It's very close to TCP connection. But you can plug in a sub-protocol, which in this case, Stomp we chose as a good option. And Stomp is a simple messaging protocol that gives you the constructs for doing pub-sub. In other words, you have clients that are subscribing for certain things they're interested in, and then the server, when there's a message and sees that somebody subscribed that matches to that message, will send it down. So for that, we have a built-in simple and external broker. That's a piece which automatically knows how to deal with subscriptions and how to find who is actually matching a particular message and to send that notification down to them. Those are the kinds of things that become of interest when you are in a messaging architecture. And then we also have message mapping methods there for application work, which essentially is similar to the request mapping, kind of a familiar programming model that you know from Spring MVC, but on the WebSocket side. So WebSocket is useful for more advanced messaging needs. So if you're building collaboration style application, games. You have a lot of events that are flowing back and forth, and really you want to be on that sort of level to be able to deal with complex subscription style needs. And the other point that's important here is that this is a very different architecture from REST. So with REST, we have what we know about REST with HTTP requests and how we process them. With messaging, this is a very different architecture. That's closer to, if any of you have worked with JMS or Rabbit, it's a lot more on that side. So it takes a little bit more, actually, to make that switch. Now, in Spring 4.2, basically, we looked at server-sent events, and we already had WebSocket messaging, which can actually fall back to streaming, and it gives you full pub/sub capabilities. So it was a little bit the way that we came to this was, well, do we really need server-sent events? And we decided that we do want to add that to make where we started from complete. So in 3.2, we started with supporting async requests with long polling. Then we added WebSocket messaging. But if you wanted to do HTTP streaming yourself directly without going into WebSocket, then really this is what this is about. And it's rather simple to use. Again, that's the appeal. You simply return a response body emitter from a Spring MVC method instead of in places where you might normally have a response body annotation. Or you can also return a response entity, which contains a response body emitter, and then you just start emitting objects on that object. And what that does internally is each object is serialized using a message converter, just like with response body, except this gives you the opportunity to do it not with single object, but basically do it with many objects over time, effectively streaming. And it looks something like this. You have a request mapping method. You're returning an emitter. You're creating the instance of that emitter directly in the controller. And then from some other thread at a different time, you're emitting these objects. And in this case, well, I'll talk about where the emitter instance is actually being stored, and we'll take a look at an example. But the media type, which you see here, so this is, if you imagine what happens with streaming, we have to set the response headers first thing. Then we start emitting objects. At this point, it's too late to change the headers. We're just streaming at that point. So here, the media type is only used to indicate which message converter should be used. What are we actually trying to serialize? And the client has to pretty much expect what sort of data will be coming down on that connection. So for this reason, we have server-sent events, which actually gives a little bit of structure around the output. Now, in order to, if you think about this, there are many clients coming in and reaching this method, and you want to be able to broadcast. That's sort of the idea to all of them. So you want to implement some kind of pub/sub, and you have these response body emitter instances, and you have to keep them somewhere, and you can do that in the controller itself, or you can put them in some other component that might be connected to a messaging system. You're waiting for external events, and when they arrive, you just go through the emitter instances and decide which ones of those should actually get that message. And there's an on-completion callback on the emitter, and that you can use to immediately register a cleanup logic so that wherever it's stored, it gets removed. Effectively, this is manual pub/sub for all the connected users. And if you compare that to the Stomp WebSocket solution, it gives you a messaging protocol with built-in pub/sub. That's something that's available out of the box, plus the ability to express things like subscriptions. Then on top of that, we have server-sent events. It's actually only a subclass of response body emitter, so it's a very simple extension that effectively does exactly the same thing, except it adds some formatting around the objects that are being serialized. So if you see here, that's server-sent W3C specification, which defines what this markup should look like, what the response body should look like, and you have things like well, they're a little bit like name-value pairs. You have an event label, which gives you the event name. And then you have a data label, which is the actual data for each event. And in this case, we're sending JSON as part of the data. And what you see here is actually different events being sent at different times on the same connection. And the example looks very similar. The main difference is that you have this chained API that allows you to build up the server sent event, and then it adds the server sent event markup around it. And there's one more option which is related to this. What if you want to do HTTP streaming, but you don't necessarily want to use a message converter? Maybe you just want to write directly to the output stream. In that case, you can do streaming response body. And it looks like this. You're basically just returning a streaming response body, and that gives you a callback to an output stream. And this callback occurs in a different thread, not the servlet container thread, but one that Spring MVC gives you. And essentially, that gives you an opportunity to write directly to the output stream. So let's take a look at some code. So what I have for the application here is actually two applications. We're going to take a look at cross-origin requests as well in a little bit. But the first part, that's the Web MVC application, and it's a Spring Boot application. The way I generated it is I went to start.spring.io, and I just picked the options for web and WebSocket, and that gave me a project to start, and then I just added a few more things there. How is the font in the back? I know this is a little bit fuzzy, but okay, good. Anybody would like it increased a little bit? That's probably more important. Okay, let's try this. Good enough? Okay, all right. Right, so what we have here is an application class from Spring Boot with a main, and we have a little bit of web configuration here. You'll see that I'm setting the default timeout to -1. So with async requests and HTTP streaming, by default, there's a timeout built into the servlet container, which I believe is 30 seconds. So this is a way to centrally flip that and say, don't time out. Just let the connections stream for as long as they want to stream. There's also a way that you can do that directly on individual instances. On the emitter that you return, you can actually create that with a timeout value as well, but this is a way to do it centrally. And I also have WebSocket configuration in order to compare to the server sent events. And that's really straightforward. Actually, you might have seen that in the keynote last night. It's just an enable annotation. And you have to indicate at what HTTP URL, this is kind of like a request mapping, at what HTTP URL you want to expose this WebSocket sock.js endpoint with sock.js to fallback. So we'll take a look at that. And then we're just going to enable a simple broker. For the heartbeats, this is actually optional. We can take it out for now. So it really can be as simple as that. And now you've got WebSocket server with a simple message broker clients can subscribe to. And then I have a server sent events controller. So that's just the Spring MVC controller. And then I have a request mapping method, which is going to return an SSE emitter. And you can see the code right below. It's just basically creating an instance of an SSE emitter and storing it in a local field here. You can see that I have a set of emitters because I want to broadcast to them. And then there's an on completion for that where I'm going to remove it. When that connection is finished, it should get removed from that set. And then there's a similar one with a response entity where we're going to simulate if there is a request parameter, then we're going to return. So sometimes instead of starting a server sent event, if you declare that on the method signature, sometimes you may want to start it or not start it. So this is what this response entity gives you a choice. You can either send no content with a null body, or you can actually start streaming data. So that's what we have. And then we also schedule a task which every 1 second is going to iterate over all the emitters, and whoever is connected is going to start sending values. And then there's a similar streaming response body. By the way, these are Java 8 lambdas. So I can show that more like this. Change that to OS. Right, so this is what you might be more used to, but the lambda is a little bit shorter instead of that. Okay, so let's go ahead and start this. It's just a simple Java run main with Spring Boot. And once this is up and running, port 80, we can go to a command line and make this a little bit bigger. Okay. Okay. So let's do curl localhost 8080. What do we have? SSC interval. Yes, SSC interval. Okay, so you can see here that we got text event stream, the content type. Right, that's the response that we get immediately. And every 1 second we have data streamed back to us. Make this a little bit bigger. Right, okay. So we'll do that. And then also we can do, of course, you can get these broken pipe exceptions if you're in the middle of writing while the client went away. Then we have SSC interval with status, so we can do it at the top, do the same with status. And if we just do it like that, it's the same thing. We just keep getting the interval ranges. But if we pass a parameter equals anything, then we get the content, no content. So it's just a, how we can do one of the two conditionally. And then we also have the streaming response body. So in terms of output, that's pretty similar. Okay, so that's sending us also something once every second, but this is streaming directly without an HTTP message converter. There's also an HTML page, so we'll take a look at that, and that's where we can look at some of the WebSocket stuff as well. And it's, well, let's bring it up. Make that a little bit bigger, and we're going to go to the network tab. So first for the interface, let me take that off. So this is the server sent event stream. Then we can start the WebSocket stream, which essentially for the WebSocket stream, that's there's a server-side controller. So this is kind of interesting. There's a server-side controller, which is a regular Spring MVC controller. And it has a couple of methods mapped to /interval with post and delete. And essentially what that will do is if I do post, in other words, if I want to start the interval posting, it has a simp messaging template that I can use to broadcast to connected users over WebSocket. And you can see here that all I have to do is just say template, convert, and send, and I'm giving it an object, which in this case is called integer value. It's just a very simple object with one field. And I'm also attaching a header with even odd. You'll see that later. There's a selector expression. And we're going to convert and send that. And basically, that's going to the built-in broker. Again, all that we did in the configuration here was to say that we want to enable a broker, the simple broker, instead of a broker relay going to Rabbit. And now we can start sending messages, and clients can subscribe to specific destinations. So that's a slightly higher level of working with an actual messaging protocol. And I can start it and stop it. So let's go ahead and try all this. And then this is my actual consumer where I'm going to start getting messages. You can see on the client side for the index page. So the buttons are connected to actions. And for the server sent events, we're just creating an event source. And then that's just a browser functionality. And then we're going to start getting messages. Then for the WebSocket consumer side, what we're going to do there is we're going to create a SockJS connection, or theoretically we could just say new WebSocket here, just using the browser WebSocket support, but we're using SockJS library. So instead of saying new WebSocket, we say new SockJS, and that gives us all the fallback options to long polling and streaming, but we're using the same API. And then we're passing that to Stomp so that we can use Stomp messaging. And what Stomp does for us is that we can say connect, and then we can say subscribe to /topic/interval. This is what we're interested in. And then we start getting messages back on that subscription. Again, that's a little bit high-level messaging. I can also send messages on that same connection just as well. So let's see what happens here. And for that, we're going to use the network tab. So first, I'm going to start the WebSocket stream. And if I go on the server side, we should be able to see now the actual streaming is happening. So you can see here that the simple broker is receiving a message for /topic/interval. And at the moment, nobody's connected, so we're not consuming anything. Now I'm going to go over to the WebSocket consumer here, and I'm not going to, there's a drop-down which allows me to pick one of the SockJS transports, but for the moment, I'm just going to let it pick, it starts with WebSocket first. So I'm going to start. And if I go to the network tab, there should be a WebSocket connection here. And you can see that we're getting messages coming down. And you can see first the Stomp connect, Stomp connected response, and then we're subscribing. And then we start getting the actual messages are flowing in. Now I can stop this. And instead of that, I can choose XHR streaming. So this is streaming over Ajax. And let's clear. Let me actually get rid of. OK, so let's go ahead and start that now. OK, so this time I have one XHR. I know this might be small to see in the back, but there's one XHR streaming connection. That's for the server sending things down. And then each XHR send. So when we're simulating a two-way connection using HTTP, we can't use one connection to go in both directions. We use one to start streaming from the server to the client. And then each time the client has to send things to the server, it has to do that using an HTTP post. But the end result is that in my application down here, you can see that we continue to receive messages here. Yeah, so the server is sending messages, and there's one session broadcasting to one sessions because there's one connected client. Right, so that's stop the server. Right. So basically, HTTP streaming versus WebSocket messaging. Again, the server-sent events we added to Spring 4.2. It's basically something that we need to have in order to have complete async support. It's suited for simple streaming needs. I mean, if you simply want to have some kind of metrics or feeds exposed to clients, then doing HTTP streaming with server-sent events, just returning an emitter from the controller is a very simple thing to do in an existing application. Of course, as you begin to do things for publishing messages and broadcasting, it starts to become more complex if you start to go into requirements like financial application or collaboration games. Then you have to broadcast all kinds of things, and you have to choose who you're broadcasting that to. In that case, Stomp, WebSocket, and the frequency of messages can also affect that choice for efficiency reasons. There, Stomp, WebSocket is a better fit. Also, Sock.js has a lot of built-in smarts. Actually, one of the transports is server-sent events. It will fall back to server-sent events in some cases, in some browsers. It actually really makes it much more complete, being able to do web messaging in a browser. Right. So moving on to the next topic, we're going to talk about CORS. Just a very brief overview of CORS, cross-origin requests. This is essentially what we're dealing is the possibility for visiting a site called eval.com, which can then make requests to bank.com, and of course, if you're still logged in with cookie remember me functionality, which hopefully the bank gets it right, but there are all kinds of websites which could expose information in this way. So effectively, CORS is a specification that makes it possible to make cross-origin requests in a safe way. Out of the box, they're not allowed, and we're going to demonstrate that in a second. In CORS, simple HTTP methods considered get, head, and post. For those, you can simply, the browser simply includes an origin header in the request, and then the server's job is to actually compare that origin against a list of allowed origins to decide whether this request should be allowed or not. For additional HTTP methods, there's a pre-flight request which has to obtain permission. It has to say, I'm actually going to submit this HTTP method to this URL, and I'm going to ask for I'm going to include specific headers. Is this allowed? And then if the server responds accordingly, then the browser can go ahead and do that. And this happens under the covers. You don't have to explicitly do that. It's built into the browsers. Now, in terms of supporting CORS in Spring, it may be a little odd that we don't have that until now for as long, but there are existing solutions, like Tomcat and Jetty have been providing CORS filters for some time, and that's a very good way to secure the application for CORS or configure it for CORS. But we decided to add first-class support in 4.2, and one of the main reasons for that is to provide more fine-grained support. So in Spring MVC, we already have knowledge about how the controllers are mapped, and that becomes very convenient base from which we can make it possible to configure CORS. So if you're just going with a central filter configuration, you start with URL patterns, and that's fine to begin with. But then in some cases, you may find yourself, depending on the application, you may find yourself that configuration keeps growing and growing as you try to become more fine-grained and specify what should be allowed where, which can become difficult to maintain. So this is why we decided to add additional support. And that's in the form of a new cross-origin annotation, which can be added to request mapping methods. And it can be inherited from the type level, which means that it's very easy to go to a specific method, and you don't have to say anything else. You just have to say, this is enabled for cross-origin, and these are the origins and additional configuration. Or you can put it on the type level, including base classes, which means that you can have an entire class hierarchy configured for CORS in a specific way. So that obviously gives you lots of power. For additional simple handlers, this is now outside of annotated controllers, but if you have something like an HTTP request handler like we do for SOC.js purposes or for resource serving, then you can implement course configuration source, and that allows you to indicate basically what's the course configuration for a given request. So there you have to do something like look at the request URL, and maybe based on a map of patterns or something like that, you have to decide what's the course configuration for that. So we have a central configuration option, just like with filters, but it's configured inside Spring MVC, and that's built into the MVC Java config and the MVC namespace. So if you're using those, you can easily add some URL patterns to begin with for central configuration, and that's URL pattern based. Again, that's somewhat similar, comparable to the filter solutions, but it's inside Spring MVC. But what's interesting here is that because it's in Spring MVC, you can layer it with the course cross-origin annotation. So you can take, we will look at the central configuration first, and then also the controller local configuration, combine the two, and then decide what's the actual resulting configuration. So this can be used for things like you might want to centrally allow the CSRF token header wherever cross-origin is allowed. And then you refine that with controller level method additional configuration potentially. The way this works, actually, it's built into the handler mapping types in Spring MVC. So it's a built-in feature of the framework, and it's always on by default. There's nothing you have to say, enable course. Course is just a feature that works. But by default, cross-domain is not allowed, which is backwards compatible, effectively. But it's one important detail there is that normally for pre-flight requests, which are HTTP options, you have to explicitly configure the dispatcher servlet to allow HTTP options, but you don't have to do that because Spring MVC supports course, we actually automatically allow pre-flight requests to be handled inside Spring MVC, and we handle that as well. So there's nothing further you need to do. It's just basically course is a feature. Just start putting the annotations, configuring it, and it should just work. So before I go to that, let's take a look. So for this, I'm going to start the same application. And if I look inside my application.properties file, you'll see that this is configured to run on port 8080. And then I have another boot application, which is nothing more than just serving the client side. It's really, that's it. That's the application. And then everything is in my resources directory. I've configured this one to run in port 9000. And then it has the same index HTML. So it's basically the same client side, which is running in a different port. So we'll go ahead and start that. Actually have to click on the app and then run. And now if I go into the browser, I can say localhost 8080. So I am actually, what I want to do is start 9000. So we'll take a look at the network tab once again. Let's remove that, we don't need it. Now if I try to start the server sent stream, and I'll show you the index page, you'll see that the index page is more or less the same, but this is the app at port 9000. That's actually going to port 8080. So that's considered a different, that's considered a cross domain request. So now if I try to start that, you can see here I have one error, and it's a no access control. Origin 9000 is not allowed. Event source cannot load. So this is how the browser actually shows it. It's a little strange that it's a 200 response, but this is how. Okay, so let's go ahead and fix that. If we go to the server SSE controller, SSE controller, and we'll just enable it at the type level. Cross origin, and we'll allow 9000. And we'll restart the app at 8080. Okay, so now if I go back here, now my data is actually flowing, as you can see. So now everything works. I've allowed port the local host at 9000 to work as well. So let's stop that and see what happens with the WebSocket side. Get rid of that. So here, it actually failed as well. And let me try to force it to WebSocket. Let's try that. Okay, so actually even the initial info request fails. That's, so SockJS, essentially before it actually decides which transport to use, it will send an initial info request, and even that's failing. So what we'll do is we'll come to the WebSocket configuration. And we're going to do here allowed origins, and we'll add a couple of origins. Localhost 8080, and actually the one we want to add really is 9000. But at the moment, and there's a ticket for that, we actually need localhost 8080 as well. And so that's, it should allow same origin requests, but this is something that we discovered just recently. But the workaround is basically that you include the same origin as well. And let's go ahead and restart. And now if I start the WebSocket, let me clear that. Okay, so it took a little bit to start, and you can see the WebSocket here. And of course, in order to make it work, I actually have to start the WebSocket stream. And now I should start getting data flowing in. Yeah, so those are just two, as you can see, let me stop this. Well, I can just minimize it. Right, so those are just a couple of examples. First of all, in a controller, I can use the annotation, or if I'm using a resource HTTP request handler, then there's a way to allow it explicitly. And also the MVC Java config and XML namespace have options for centralized configuration as well. So let's stop this and say it again? Expose headers, like what headers you want to expose, or should I just... Yeah, so the question is, do we expose the full set of things that, and yes, the answer is that we do allow all of that. So if you go, for example, to the SSE emitter, you can see that, well, let me go into the actual annotation. You can see here that we have multiple properties for origins, for allowed headers, exposed headers, methods, credentials, and max age. So the full configuration, basically. Yeah? So the question is, can we use a spell expression inside of these properties? At the moment, we don't support any expressions inside, but I think that's a good suggestion. We support property placeholders on the request mapping annotations, but it will make sense. So file a ticket, please. Anyone else? Conference-driven programming. Right. So now, so all of this is happening inside Spring MVC. And one question that comes up is basically if you have Spring Security in front of that, what should be done? Now, in general, you don't need to do much, but with Spring Security, you do have that one consideration that pre-flight requests are HTTP options requests. So now, the other thing is that pre-flight requests don't have a cookie, which means that you don't really know who the user is. This is just part of the course specification. And in general, it's not a really good idea to enable any HTTP options requests to come in. And that's actually what we're looking at here, because Spring MVC can handle pre-flight requests. But if you use Spring Security, that may be in front of not just Spring MVC, it could be in front of other frameworks as well, depending on your application and configuration. So just be very careful when enabling HTTP options in your Spring Security configuration, because that can create possibilities for exploits. But if you're using Spring Security with Spring MVC 4.2, for the moment, you're going to have to enable to allow HTTP options requests to come through, and Spring MVC will handle pre-flight requests that way. But there is a Jira ticket, and that's a link for improving this so that Spring Security will specifically provide an option to enable pre-flight requests when it's being used in combination with Spring MVC. So that's a little bit more targeted and focused on doing exactly what needs to be done. There's also a coarse filter. So for example, if you want to use a coarse filter that we provide that's built into Spring MVC, and you don't need the fine-grained configuration, then it's just a simpler thing to do, and you don't need to worry about Spring Security because you can put that filter in front of Spring Security. This is comparable to using a filter from Tomcat or Jetty, except it's provided now, it's built into Spring MVC. Okay, so the next subject is HTTP caching. So we have recently, well, not so recently anymore, but an HTTP 1.1 spec updates that did a lot of clarifications around HTTP caching. And also we have HTTP 2 now. So some of the defaults that have been in the framework for HTTP caching headers were a little bit out of date, and so we decided to do an update on the default settings in line with current browsers and proxies. We also improved options for working with HTTP caching headers inside annotated controllers. So typically until now in Spring MVC, what you see is centralized configuration for managing headers, something like an interceptor where you define what kind of headers you want per URL pattern. But we wanted to make sure this is also local to MVC controllers. And we also wanted to provide some guidance for how to set response headers, because there are various combinations of things you can do. And we wanted to give kind of easy idioms, make idiomatic things easy, but also have the option for advanced configuration. So we'll take a look at that. So the key thing is that we have a new CacheControl type. This is new in Spring 4.2, and it's a convenient way to build the response headers in terms of caching. And it covers the common use cases. So for example, you have max age, which is the way where you want to go to indicate that you actually want the response to be cached for a certain amount of time. For no store, this is where you want to completely prevent cache. No proxy, no browser should store this in their cache. And then you have something called conditional cache, where you're saying don't, well, cache this, but do it conditionally. And you have to use additional validation like e-tag and last modified, where the browser sends and says, has this changed since that time? Or here is the last E tag that was given to me. Does this resource still match? And there are various other cache control header. This is really the modern header alternative for caching with HTTP. And there are various kinds of advanced directives in that response header, which were not explicitly supported in our existing classes. And that's why the cache control builder will help to do any of those. So now if you look at the web content generator, which is the base class for pretty much anything that supported response caching headers on the response, so most likely you're using that with the web content interceptor, but you might be using it with the resource HTTP request handler as well. Now the default settings there have been revised, so there are no more HTTP 1.0 headers like expires and pragma, so that's gone. But you can still use it. You can use the setters to make that happen still, but they're deprecated methods. And we have also kept one of the methods called cache seconds. It's a convenient shortcut with certain conventions. If you say 0, -1, or a positive number to indicate those three use cases which I talked about, which is the max age, no store, and no cache. The interesting thing is that Web Content Generator now accepts the cache control type, and that allows you to specify the full range of directives that are there. Now, inside MVC controllers, you can return a response entity with cache control. So that's another place where this cache control is supported. So you can say, maybe you've seen this, the response entity has a fluent builder. So here we're building a 200 response, and then we're saying cache control. We want to cache this for 30 days in this case. And we're also adding an E tag, but we could also add a last modified, which is actually recommended to have both. And then the browser will effectively cache this for 30 days with that E tag to check whether the content has changed. And the other thing is that once you do that, we have an opportunity to automatically check. So you've specified an E tag. We have automatically the ability to check whether the client has sent us a conditional validator header with the E tag that it's holding on from before, and we can compare the two. And if they're the same, we don't need to send the whole response back down, so we're just going to send the 304 back. So that's kind of a built-in feature now with response entity. Of course, the alternative is you can do this manually by hand. So this is something that's been supported for a while, that inside a controller method, you can just take the request and you can say check not modified and provide a last modified or E tag or both. And if that returns true, then you simply return null and the response is considered a 304, handled. So that's kind of something that's been supported in the controller programming model for a while. But now it's automated with response entity. And also in resource handling, you can configure now the resource handler registry. You can specify a cache control. So that's a third place for serving resources where you can use this cache control type. And there's some additional reading. If you haven't, if this is a topic of interest, actually there's a really good tutorial by Mark Nottingham, who is involved with HTTP specifications. And he has a very nice breakdown of effective ways to do HTTP caching and what are the important headers and considerations around them. So if you want to learn more about this, that's really the place to go. The next thing's composable request mappings. This is easy to show in a slide like this. If you have something like what's at the bottom, a request mapping method get, which produces application JSON, well, now you have the ability to express that with your own custom annotation, like shown above, called post JSON. And so basically, I'm probably missing a slide here. I should show how this is done, but the post JSON annotation is your own custom annotation, and that's annotated itself with the request mapping annotation. That's called a meta annotation. And basically, you can now design your own custom annotations. If you have common cases where you see a lot of repetition in your request mapping annotations, you can now instead replace that with your own shortcut annotation. And if you go through that exercise and you find something useful, please tell us, because we are actually gathering information and trying to decide on providing some kind of shortcut annotations built into the Spring Framework, maybe for version 4.3. But in order to choose something, it's very important to hear from you. So if you use this, please let us know. There's a ticket in Jira, and there's also a project, a temporary project, Spring Composed. You can take a look at that. And this is not necessarily just for Spring MVC. This may be supported in other parts, these kinds of shortcut annotations. In terms of Jackson, this is a rather important integration these days for the Spring Framework. We always have new features for that. In 4.2, in 4.1, we had support for JSON view annotation on request mapping methods. So the TLDR on that is if you want to return the same object, but on this page you want a little bit of subset of the data, but on that page you want the full data. How do you do that? And that's the JSON view annotation that's supported in Jackson. And you can now put that annotation directly on request mapping methods, since 4.1. And we will, based on that, serialize or pass that to Jackson. So Jackson will serialize a subset or the full object accordingly. But now in 4.2, when we designed this in 4.1, we said, why would you need that on the input side? But before you know it, requests came in. So apparently it's useful on the input side as well. And when you have a request body, you can specify now a JSON view annotation on that as well. So you're reading only a subset of the input, you're populating only a subset of the object that's coming into the controller method. There are also certain Jackson modules that are now auto-registered. You see the list here. And internally, we use this Jackson 2 object mapper builder, which you may not have heard about, but it's a really, really useful thing because it allows us to provide certain defaults when a preconfigured object mapper, essentially. And if you want to further configure the object mapper, instead of creating it by hand, use this builder, and that means you're starting from the same defaults, and then you're adding further additional changes on top of that. And you can use it with the XML data binding and the JSON data binding. It's the same builder, so it's convenient for that. You can reuse your customizations for both. In terms of the programming model, if you have exception handler methods, you can now add, there's an additional method argument type which is supported called handler method. So that tells you what controller method was actually used to handle the request. And if you use that in combination with controller advice, which is basically global exception handler methods, it might be useful to know where is the exception actually, which controller method was trying to handle this request. We support char sequence as a controller method return value now, which means that you can return a string builder or string buffer instead of string, as well as Groovy GString, which is actually where this came from as a request. The init binder method, so this is kind of a little change which is quite meaningful. So if you have formatters or converters, they are probably registered globally with a conversion service. But sometimes you may want to register them just for specific fields within a controller and not have them have impact for the entire conversion service. And that's where you can use an init binder method now. And on the data binder, you can register formatters per field or per type. And that's not going to affect everything. We've also extended the support for async return value types. In most cases, you probably are returning deferred result, but if the underlying service is giving you a listenable feature, or maybe Java 8 completion stage, you can just return that from the controller method. And internally, we adapt it to deferred result. And also we've made it easier. We realize that actually it's harder than it should be, but it's easier to adapt other types like RxJava Observable or React to Stream. Anything which is going to give you a result at a later time is now pretty easy to adapt to different result. So JavaScript templating, I'm not going to go into the topic in a lot of detail. It is an interesting topic. So basically, just to briefly give you an idea of what this is about, where this is coming from, traditionally we serve HTML for a long time, and then we enhance it with JavaScript to give it functionality. And that's the conventional wisdom. There is now a trend towards simplifying UI on the client. If you have advanced single-page applications and doing a lot of stuff with multiple components on the page, there's a trend towards creating user interfaces with JavaScript. In other words, generating the UI using JavaScript, kind of like the way you might use a Java API to create like Swing and others. And this is really something which arises from the pain of building single-page apps, addressing the challenges for that, as well as for mobile devices, kind of beyond like the JMobile query. If you branch out into PhoneGap and others, then you might find yourself rewriting and not being able to reuse a lot of what you're doing necessarily with server-side rendering. And there's a library called React that some of you may be familiar with or even using. Actually, just a quick poll. Anybody using React? See a few hands. It's essentially, that's a library which is developed at Facebook and Instagram. It's been picked up by major internet players rather quickly. It's, the approach there seems to be quite influential, and others are moving in that direction with essentially a virtual DOM being created for you instead of directly having you perform updates on the DOM, which is slow. And the updates to the virtual DOM are then used to decide how to change the actual DOM, and all of this is done transparently for you, which means that you don't have to be on that level, and it's a lot faster and efficient. Now, if you embrace the React, and because of the virtual DOM, there's also server-side rendering possibility. Now, if you embrace the React approach, then server-side rendering has significant benefits, using JavaScript, that is. So if you're using a JavaScript UI for your Vue technology, basically it makes sense to not send that to the browser to run and build up the UI. It makes sense to actually run it on the server side first, to use the server-side processing resources, and then send HTML, the generated HTML, down to the client. So this is useful for search engine optimization, so they understand what's the HTML. And it's also useful for page load times, especially on mobile devices. What we've done for Spring 4.2 is that, first of all, we've added support for JSR 223 scripting engines. So that's any scripting engine on the JVM, including JavaScript, Jython, and others, Groovy. Basically, you can now plug that into a new Vue technology choice, and that's the script template view and related classes like the script view resolver and script configurer. It's very similar to using something like FreeMarker or the Groovy markup that we added in 4.1, as well as to TimeLeaf, except in this case, well, in terms of configuration, otherwise it's rather different. So you basically use JDK 9 Nashorn as a scripting language, and that allows you to execute some JavaScript on the server side inside Java. So here we're going to execute the React library, and that's going to generate the UI that we can send down to the client. And as I said, this is a rather interesting topic that if you want to learn more about, you can see the talk by Sebastian later on today. I believe it's after lunch, first talk. And that's called Isomorphic Templating with Spring Boot, Nashorn, and React. Again, if this is of interest, take a look at that talk. It'll give you much more detail. And you might want to also check the talk by Matt Rabel tomorrow, who's going to talk about client-side JavaScript frameworks. Another feature we support in 4.2 is byte ranges, HTTP byte ranges. So what we have here is the ability to download partial content, where the server basically gives you an accept ranges response header in order to indicate that it's capable of doing that. And then the client can indicate through a header which bytes it is interested in. So this is useful when you work with large media files, or you want to request some part of a file or resume something. So in 4.2, we have essentially an HTTP range type, which is just basic support. And then we have HTTP headers, and resource serving actually has that as a built-in feature. It advertises to the clients that it supports ranges. And then if the client sends a range request, we will give exactly what the client is asking for. Now, maybe you don't care about this feature, but the particular request that came in was by somebody who was serving video files to iOS devices. And we said, sure, why not? Let's make that possible. So here's an example of that. You can do a curl with a range header, and then in this case, you can see that it's going to the server. It's including the range header with specific byte range, and then the server responds with partial content. This is actually coming from Spring MVC, so this is built-in support now in Spring MVC.
What does that look like on the endpoint side? Does it just render everything, and then Spring MVC just selects this specific portion?
Yeah, so what does it look like on the server side? So this is specifically for built into resource static resources, when we serve static resources. Basically, when we find the resource, just before rendering the body, the actual file, we look at the range header in the request, and then we write only a portion of that to the response. So this is not something related to the controller methods. Of course, if you want, you can build that support yourself. We have the basic support, and you can see how it's done in resource handling, but where we could, we made it automatic, like resource handling. Now, on the client side, we now have support for the OK-HTTP library, which is a lightweight HTTP library that seems to be popular on mobile devices as well. And this basically gives you the full list of HTTP libraries that we support now with REST template, which is just the JDK facilities, and then Apache HTTP components, which has been there for a while. Netty since 4.1, and also OK-HTTP now, so you have a choice of these. And of course, you have the REST template and the async REST template, which means that if you want to get it back asynchronously, you can do that with the async REST template. You'll get the response given back to you, so you're not holding up the thread, which is convenient if you're doing a lot of concurrent requests. There's another small but useful feature which might be of interest for flexible URI template handling. So for a long time, we've been getting questions around the way that encoding works with URI templates. And this kind of came in as a useful solution that has multiple use cases. But basically, there's a URI template handler which allows you to decide how to expand a URI template into a URL. And by default, we use the URI components builder internally for that. But essentially, it's a property on the REST template, and you set that property, you give it a URI template handler, and then you can customize things. So for example, if you wanted to insert some prefix into every URL, you have a REST template, and you, instead of in every URI template putting a prefix, that can be done automatically through this extension point. Or this was one of the requests, you can switch from path to path segment encoding. This has been a long-running question that keeps coming, so finally, hopefully, well, we have an answer for it, so that's good. And then if you may have come across this, but there is an RFC 6570 for URI template syntax, kind of more advanced URI template syntax. I don't think we're headed in the direction of fully supporting all of those options. They seem to be rather extensive. It's not clear that that's the 80% cases, but there are libraries that you can use if you want that full syntax. So this gives you the ability to basically replace what we do with URI templates, which is our own approach that has grown over the years. But if you wanted to switch to the RFC syntax, then that's something that gives you this choice as well. But most likely what this means here is that you can do things like a custom prefix in front of all URI templates, maybe for locale reasons, etc. On the WebSocket messaging, just a few slides on that. First of all, for the simple broker, we now support heartbeats. How many are using the WebSocket support with the Stomp broker? Okay, quite a few hands. How many of you are using the simple broker for your application and it's okay? All right, a couple of hands. So we've seen that the simple broker actually is used, and if you're using it, it really makes sense to have heartbeats because that's going to detect when clients go away, and it just makes the server more robust. Now, in order to make that happen, you do have to set a scheduler, but it's fairly straightforward, and I actually have that in the sample app. I don't think I have time to demo it, but it's basically just a scheduler and that I created for myself, and I marked it primary to make sure that it doesn't collide with any other schedulers that exist that are used for other reasons. So for auto wiring by type, this is the main one that's always going to be picked. And then you simply have to set it over here, set task scheduler, and I've auto wired in the actual scheduler being in here. And that enables heartbeat support. We also, for the simple broker, we support a selector expression. So you can say when you're subscribing, you can provide an expression which is evaluated against the headers of messages. So now you can receive a subset of messages. So in this case, in the example, I have interval range with odd and even numbers, and I can here say if the header has a parity, if there's a parity header with value of even, then I'm only going to get those messages. I'm not interested in any others. Multi-server user destinations. So if you're using RabbitMQ or something like that in the backend for your actual broker, then you could have a multi-server scenario where you have, say, 5 Tomcat servers, and then you have a shared Rabbit broker among them. So now if users connect to one of those servers, the other servers are not automatically aware of users on other application servers. So this feature makes it possible to use the user destinations, which is a way to target, to send messages to a user without knowing whether they're connected or whether they have a session and what the session is. You can send them a message. And with this support now, you can be connected to any of the Spring application servers, and then from another server you can send a message targeted to that user, and that will pass through Rabbit if it cannot be resolved locally. So it will reach a user on any Spring application server. We also expose connected user information. So if you want a feature, for example, something that came up recently, say you're looking at booking at hotel and it shows you 8 other users are also booking or looking to book at this hotel at the moment. So that's the kind of information that this exposes, who are the other, what users are connected at the moment. And this is a simp user registry bean that you can inject into any class and then get the information from it. We basically keep track of who is connected and collect that information. And one thing that's worth knowing is that essentially, in order to make this work, each server will broadcast the user information every 10 seconds or so. And if we don't get the information in 20 seconds, that's considered stale, and we forget about those users. So that's the way it works out of the box, but you might want to configure those settings a little bit depending on you know, how much you care about this. Or perhaps even turn it off. We have a Stomp client, and I'm just going to show that quickly. Let me start the application. It's already running, okay. So I don't need to start it. And for the client, we have, it kind of looks like this. It's basically a Java version of what you saw in the client, where we have, first of all, a WebSocket client, and then we're creating a SockJS layer on top of that. And you can see here we're configuring it with WebSocket and also XHR for fallbacks for HTTP streaming and polling. And then we're creating a Stomp client, which is using that SockJS and WebSocket underneath. So it's pretty nice because if you, for example, want to test your Stomp application, it's much easier to do that from Java. And that's really what this makes possible. So if I run this here, oh, and what it looks like is there's the session handler. So once we're connected, we're going to subscribe to a topic, and then when we get messages, we're just going to print them out. So let's run that. And you can see here that it's getting messages and decoding them and printing them out. So in theory, one of the advantages of Stomp is that there are many implementations, both client and server-side. But for whatever reason, I mean, I guess Stomp was created for scripting clients originally, and it's useful for web use with Stomp.js. So those are the popular options, but for some reason, on the Java side, the support is lacking, which is why we decided to add our own. And fortunately, it wasn't too bad because Stomp is, after all, simple text-oriented messaging. Oops, where's that? Interesting. Okay, it's just switching to the wrong thing. All right, programming model changes. We have property placeholders supported for message mapping methods. JSON view for @payload input arguments. This is kind of similar to what's happening on the controller side for Spring MVC. For send to annotations, you have destination template variables that you can use, so you can kind of make a dynamic destination. Also support for async return value types. Global message exception handler methods. So this allows you to handle an exception through a controller or device now. This is something that you could only do on the Spring MVC side. And we have a new OXM marshaller based message converter. And if you're interested in this topic, later today, there's a talk by Sergi, which takes you from 0 to hero with Spring WebSocket. I recommend seeing that if you want to learn more about the WebSocket side of things. So thanks for listening, and I'm going to open for questions. I guess we have a few minutes. If not, you can come later as well. Yeah. So the question is about what's coming on the reactive side, especially with Spring 5 announcement. So we had one talk yesterday. I would recommend also coming to a talk we have tomorrow where it's going to be a little bit more concrete, talking about the web application space. So yesterday was a little bit more theoretical, the foundations, which you absolutely need in order to understand this topic, but tomorrow is going to be a little bit more about the web application space, leading up into what we're doing. We actually already have a code repository with a little bit of experimental work that you can take a look. There's a Spring Reactive project. And tomorrow we're gonna basically explain what we're doing there. This is the second talk tomorrow. It's called Reactive Web Applications. So just search the reactive keyword. Yeah.
So
So the question is about the support for RxJava observable. So it's not built into Spring MVC if you have a observable return value type, but it's extremely easy to register a custom return value handler in which you basically register with the observable, and when the result comes, you set the deferred result. Or if you're using the server-sent events, you register with the observable, and as you start getting data, you're just passing it on to the emitter. And then when you get on complete, you're just saying complete on the emitter. So it's extremely, like a few lines. It's been done a few times, actually. I think one of the Spring Cloud projects has it. And also Chris Richardson, I think he's giving a talk here. He's got it also in his sample. One in the back? Yes. Could you repeat that? CSRF protection? Spring Security, I would recommend. Spring Security has specific support for that with Spring MVC. Well, with CORS, it's basically whether you want to allow requests from other origins. So that's something that you would configure. And then the relationship to CSRF there is that if you're doing any kind of put or delete HTTP methods, you'll also want to make sure that the CSRF token header is allowed for CORS purposes. So that's something that you would add to your CORS configuration. All right, thanks for attending and listening. And if you have anything else, please find me.